In this lesson, we're going to talk about the two special right triangles. The first special right triangle is called the 45-45-90, and we'll see why in a moment. We're going to start off with a square, and we know that a square is equiangular and also equilateral. Now let's say this side measures x, then all of the other sides would have a measure of x. Now what we're going to do is we're going to draw a diagonal. It doesn't matter which way we go. We can go this way or we can go this way. And if we remember our properties of quadrilaterals from geometry class, when we draw a diagonal, what we actually do is bisect this angle here. This gets bisected into two angles of equal measure. So if the entire angle was 90 degrees, the bisected angle in here would be 45 degrees. And that's where we get our 45-45-90. Now we have almost a complete picture. We've got three angles and two sides. It would be nice if we could find the measure of this third side. And you know how to do that. If you've got two sides of a right triangle and want to find the third side, we've got our Pythagorean theorem. Pythagorean theorem. So here we go. Let's substitute. A and B are both equal to x. We can combine like terms and then take the square root. Now you remember when we take the square root, we want to think about both roots. There's a positive root and a negative root, except in this case we'd reject the negative because we don't want a measurement to be negative. We don't want a length to be negative. So now we've got radical 2x squared. We can simplify that. We'll take out the x, radical 2. So that is the length of the third side over here, x radical 2. So let's draw this again without this other triangle here making up our square. The 45-45-90. This side is x, this is x radical 2, and these are 45 degrees. Also notice the type of triangle it is. This triangle here is a right triangle, but it's also isosceles. It's got legs of equal measure. So sometimes we refer to this as an isosceles right triangle. So if you hear anybody talking about isosceles right triangles, they're talking about the 45-45-90. So what's cool about this triangle is that, let's say you know that you've got an isosceles right and that the measure of one side is 7. You now also know what the other two sides are. That would have to be 7, and this would have to be 7 radical 2. So all the sides will always be in the same ratio, x to x to x radical 2. All right, now we'll talk about our second special right triangle, which is the 30-60-90. Now that's not going to come from a square. We're going to start with an equilateral triangle. So an equilateral triangle has sides of equal length, but it's also equiangular. These angles have equal measure. So we know the sum of the measures is 180 degrees, and there's 3 of them, and 180 divided by 3 is 60. So these are all 60 degrees. Now we're going to do something similar that we did with our square. We're going to bisect an angle and draw an altitude right here. So when we do that, what we have is two right triangles that have created the equilateral triangle. And now we're going to focus just on the right side. So see, we've got 60 degrees, this is 90 degrees, which leaves this angle right in here that has to be 30 degrees. One reason is because this angle was bisected by the altitude. The other is that 90 plus 60 is 150. We've got 30 degrees left over. So now let's focus on the sides. Let's say that this side here has a measure of 2x. Well, again, this is equilateral, so all sides would be 2x. But this altitude is going to bisect our side here. So if this whole thing is 2x, then from here to here would have to be just x. So once again, we've got a right triangle. We have two sides. We want to find the third side. We use the Pythagorean theorem. So a squared plus b squared equals c squared. Except in this case, we have the hypotenuse. The hypotenuse is 2x squared. Let's make b x squared. We're looking for a. So we'll simplify the right side. We get 4x squared. A squared equals 3x squared, square root. Remember, we're going to reject the negative. And we've got x radical 3. So that is our third side over here. This here is x radical 3. So let's write this over nice and neat. Our 30, 60, 90. Here's our 90, our 60, and our 30. This would be x, 2x, and x radical 3. So now it's important that you memorize the angles relative to the sides that they're opposite. 30 is opposite x, 60 opposite x radical 3, 90 opposite 2x. So let's say you were given a triangle and you knew that it was a 30, 60, 90, and you also knew one of the sides. Let's say that this is 10. Well, opposite 90, we've got a measurement of 10, and we know that that's 2x opposite the 90. This is 2x. So x would just be equal to 5, and x is across 30. So across from 60, we'd have x radical 3, which is just 5 radical 3. And that is it for 30, 60, 90. So your job is to memorize these two triangles, the 30, 60, 90 and the 45, 45, 90. So one more time. You can look at them together. Here's 45, 45, 90. X, x, x radical 2. And our 30, 60, 90 with x, 2x, and x radical 3.